All right, the point of the first discussion about different base systems is pretty simplistic in that the whole purpose, is just to connect it in terms of the packaging to base 10 and also the powers of 10. We also connect to the powers of whatever base system we're working in. So the purpose of the initial conversation I have with students is what are we packaging by in this base? And how does that correlate to giving each place value a base and then to an exponent number? So that's the relationship that we're trying to make right now. So this is a very early stage in the place value unit because you want to juxtapose it to that initial video about base 10 so that the relationship can be formed and that so they can see the similarities across different base systems. So I already have the images put into the place value chart, but that doesn't mean that you can't actually manipulate blocks as well. On the document, I included a great virtual manipulatives website where you can adjust the base, and they're different colors and they're 3D and they're very easy to picture. Also, a lot of base 10 blocks are styrofoam, and you can kind of cut. That's what I did in my class. I cut out the actual blocks so that students could actually touch and move them, and that helps. And also, I mean, they're so simple that you can cut them out, and because the highest digit in each of the places will be 2, so you really don't have to make a whole lot of each block. But the first thing I talk to students about is I tell them that we are using a base 3 system and that we're going to learn what that means. I'm going to tell them that we already, we've studied base 10 and what that looks like when each place gets successively bigger. We've also talked about how each place has its own base 10 to an nth power. So what we look at first is the ones place, noticing that it still is the ones place. And then what I do is I tell the students that I'm going to try to reach the maximum capacity of this place. So at this point, I ask students, do I need to regroup at any point? Do I need to repackage? And they say no, because they know that we're working with a base 3 system. They can kind of draw the connection that we're grouping now by 3s as opposed to 10. So I pull out a second one and ask students if we should group yet, and they say no. And then as I pull out the third unit, students notice with the blocks, in close proximity to them, that there is a more efficient packaging. And then one student will usually reach and grab the 3's rod and trade out these 3 units for a rod. And the students have another, just like in the initial video, they have a place value chart that looks just like this one so that they can keep track of what's going on in their own notes page. So what we talk about is, okay, well look, the rod, it's 3 ones. It's 3 groups of 1. So what that means is that this place right here, whatever this place is 3 times larger than the ones place. And this is where students their minds start to sweat. This is a little bit of a brain sweat. I asked them what place this is. And, looking back at the base 10 blocks, the actual block is a representative of the value of the place. So then they understand that this is the 3's place. So the 1's place, this is the 3's place. And that the 3's place is 3 times larger than the 1's place, just like our initial video on base 10. Then what we do is I will pull out, okay, so here's the second rod. Am I meeting the quota? Do I have to repackage yet? Let me grab this. Students will say, no, you can still have room for one more, but at the point where I bring out my third rod, there is a more efficient packaging, and that is the flat. Students will get rid of these. And what they'll notice is that this flat is 3 groups of 3. It's 3 rods, and each rod is 3. So it is 3 times the size of the place before it. So I then asked the students, what is the name of this place? And because these blocks are representative of the place, this is the 9's place. And the 9's place is 3 times larger than the 3's place and 9 times larger than the 1's place. So students are saying, oh, well, base 3, we're packaging by 3's, and as opposed to base 10, we're getting each place is getting larger by 3 times the size of the one before it. So moving from the 9's place, well, okay, so here's my second 9. Here's 2 9's. Come on out. Here's 2 9's. Do I have to repackage yet? No. On the third, I do. There's a more efficient packaging, which would be the cube. And this cube is 3 groups of 9. Remove these out of the way. This cube is 3 flat stacked on top of each other. It's 3 groups of 9, being that the bottom layer is 9. Oops, I accidentally got rid of one of these on it. Let me pull it back up. It's 3 groups of 9, meaning that it is 3 times the size of the place before it. It's the 27th place. So there's 27 units here. Well, if we counted these out, there'd be 27 of them. It's 3 times the size of the 9's place because we're packaging by 3. Each successive place is 3 groups the size of the place before it. So now we can see this pattern is formulating. We have, 3 groups of 27. So this is the 81's place. You can see, here's that first cube. Here is the second. Here is the third. So this is actually that cube, and we're tripling it. We're multiplying it by 3. Then the students can see that whatever this place is, the 81's place, to move forward, it's 3. The next place is 3 times the size of the 81's place. So this entire rod is this first layer, and it's tripled. Okay, so we have 81 3 times. So this is the 243's place. It's 3 times the size of the 81's place, and therefore it's 3 groups of 81. Okay, computer's being slow. When you see, it helps, I think, to circle the actual block as it changes from place to place, because then you can see that this is 81, this is 81, this is 81. It really is 3 groups of 81, or the place before it. And then, this entire image, or this entire block, is one of the stacks of this cube. So really what it is it's 243, and then here's the second 243, and then here's the third 243. It's 3 times the size of the place before it, so meaning it's 3 groups of 243. So students are like, oh, this looks really familiar. It's we're moving not by 10 times the size of the one before it, now we're moving by 3 times the size before it. So this is, an opportunity to talk about, okay, well, this is base 3. Where are we getting that? Well, similar to the base 10 system, each time we grow by a place, we're getting 3 times the size of the one before it. So, to look at the 3's place, we multiplied 3 by itself once, so this is 3 to the first power. Moving over, we've gone 3 times 3. 3 times 3, 3 squared. Moving over to the 27th place, we've gone 3 times 3 times 3. 3 times 3 times 3, or 3 cubed. When we get to the 81's place, we've gone 3 times 3 times 3 times 3. We multiplied 3 by itself 4 times, or 3 to the 4th power. When we get to the 243's place, we've gone 3 times 3 times 3 times 3 times 3. Meaning we multiplied 3 by itself 5 times. So it's 3 to the 5th power, and then so forth, 3 to the 6th power. It functions just the same as a base 10 system, except now we're working with powers of 3. Each place has a base 3. So students start to draw those connections. Now, I'm sure if you set this up the right way for students, you could give them, say, okay, make the place value chart for base 5, or make the place value chart for base 4. And using what they know about the progression of places, and the grouping, they should be able to formulate the, you know, the place value names and the exponent names, because each time you're packaging by 3 in this system, you're packaging by 10, you're packaging by 4, meaning you're getting 4 times the size, 3 times the size, 10 times the size as the place before it. So all place value systems, you know, whatever they might be, base 2, base 3, base 4, they function similarly in that way.